Okay, let's work with negative exponents. So z to power negative 8, it's going to be equal 1 over z to power positive 8. Where from it's coming? So when you have a to power, oops, this is too much. Hold on. Yeah. When you have a to power to negative n, that is equal 1 over a to power positive n. So how does this work? A to power negative n, that's a whole number, so denominator obviously is going to be 1. So if you see it, you flip the fraction, right? And negative sign also disappearing, becoming positive. That means that a 1 over a to power negative n, what's going to happen? That's right, you're going to flip the fraction with positive n. Okay, and here will be negative 1. Over 1. Okay, this is the rule we are going to follow. Okay, so let me make sure it will be visible. One, and then another one. Let me rewrite this n. Okay, much better. All right, so let's continue. Next one. Let's assume now we have 1 over, this is first one. Let's assume we have 1 over a to power negative 3. That is going to be equal a to power positive 3 over 1, which is a to power 3. All right, next one. X to power negative 6, y to power negative 2 over z to power negative 3. What's going to happen? Because let's flip first one. Negative 6, it's going to be x to power positive 6 coming down. Okay, next y to power negative 2. Okay, it comes down to y to power positive 2. Let me shade it, positive 2 and negative 2. And z to power negative 3. Negative 3, it's going to become z to power positive 3. Okay, that's how it works. Next, x to power 4 and let's say b to power negative 8. So since x to power 4 it's positive, so it stays as a positive. But b to power negative 8, it's going to go down, b to power positive 8. Okay? All right, next one. Number 5. So let's assume we have 5 x to power negative 3 and to power negative 4. What's going to happen? So we are going to distribute on every single term. So it's going to be 5 to power negative 4. and then x to power negative 3 times negative 4, it's going to be positive 12. And the result is x to power 12 will stay on the top, but 5 to power 4, it's going to stay at the bottom. So we will have x to power 12, and 5 to power 4 is going to be 625. If you're wondering how I figured out, I didn't punch on calculator. I just did 25 squared. If you are interested to also do it in your mind, you can open Mathtrix. I recorded there, so you will see how to square within 1 minute numbers that ends with 5. Okay, next one. Next one is going to be, let's say 5 x to power negative 3. That will be equal. 5 stays on the top, right? Because it doesn't have negative exponent. X to negative 3 will go down as x to positive 3. And that's it. So next one, number 7. 2x, let's say c to power 5. And to power negative 2. So what do we get? We again distribute, so it's going to be 2 to negative 2, x to negative 2, c, 5 times negative 2 is negative 10. So that is equal. 2 to negative 2 comes down, okay, which will be 2 to positive 2, or might as well, let me put 4, okay. X to negative 2 will come down, x squared positive. C to negative 10 will come down, also c to 10 positive. And on the numerator, we will have left only 1. All right, moving to next one. So it is going to be this time 8 a b to power negative 6 over c to power negative 5. So what do we have here? A stays at the bottom because it doesn't have negative sign, exponent. A stays, 8 stays on the top, I'm sorry, because it doesn't have negative sign. A stays on the top, no negative sign. B to power negative 6 come down on the other hand to denominator. And C to power negative 5 moving from denominator to numerator because it's negative sign coming to a positive side at the end in numerator. Okay, let me see another one. So x to power negative 2, y to power 3, z to power negative 8, and t to power 1. Okay, we leave it alone, t to power 1. So what do we get? Since we have negative exponent, I'm drawing fraction line because they are going to go to the bottom or to denominator. So what is going to denominator? X negative 2, so it's coming x to positive 2, and z to negative 8 coming to z to positive 8. The rest is going to stay in numerator. Okay. Next one. So 6 to power negative 2 times 2 to power positive 5. That is equal. Well, I don't have to take 2 to 5. Let's say I took the other one into parentheses because it has negative exponent, but yeah. So what do? We can't take 6 and multiply by 2. First of all, we have to get rid of exponent, which means we have to raise the number to that exponent. So 6 to negative to power negative 2, it's going to be 1 over 36, because first of all, negative 2, it's going to come down, bring down, right? And 6 squared is 36. And 2 to power 5 stays on the top, and 2 to power 5 is 32. Oops. Maybe I should go slow. These come down 6 to positive 2 and 2 to positive 5. And then I get 2 to power 5 is 32. 6 squared is 36. Okay, next one. All right, let's go to more fun stuff. Let's take 3 this time. So 3, a to power 0, b to power 3 over z to power 4. And that's all we raised to power negative 4. Okay, let's see what's going to happen. So one interesting thing I'm going to mention to you here. So let me write down right here. A to power 0 is equal 1. Okay. Okay. Which means, so this is going to be 1. And we have left what? So the rest I'm going to distribute negative 4. Here, here, and here. So we get 3 to power negative 4. B to power 3 times negative 4 is going to be negative 12. And z to power 4 times negative 4 is going to be negative 16. Okay. What do we get? 3 to power negative 4, it's negative, bringing down to denominator, become positive. B to power negative 12 comes to denominator, positive. But z to power negative 16 come to numerator, and it get positive. Okay? Another one. X to power negative 3, y to power negative 4, and then over x to power positive 6, and y to power negative 2. Okay, let's solve this one. So there are so many ways to solve this problem, but I just simplify this expression. So let me pick one of them. So first, you can, okay, I'll show both ways and then you decide which way you like it. So I'm going to x minus 3 divided by x to power 6. So we are going to subtract here. So what I'm going to get, x negative 3 minus 6, right? Because when we divide, we subtract the exponent. So negative 3 minus 6 times, and then y with y, it's too thick, okay? So it's going to be y to power negative 4 minus negative 2. Okay, and that is going to give us x to power negative 3 minus 6 is going to be negative 9. And then y to power negative 4 minus negative 2 is going to be negative 4 plus 2. It's going to be negative 2. And the answer will be 1 over x to 9 y to power 2. Okay, another method. So first you get rid of these negative exponents, which means x to negative 3 will come to the bottom, and x to 6 will stay also at the bottom. Y to negative 4 will come to the bottom with positive sign, and y to negative 2, since it's negative, will come to the top. Okay, and here we have x to 3, x to power 6. It's going to be x to power 9, right? Because when we multiply, we add exponents. On the other hand, y to power 2 divided by y to power 4, that is going to be subtraction. So 2 minus 4 is going to be negative 2. Why I put it negative 2 here? Because I subtract from 2, which is whatever result I get, I put on the numerator. If I would do, look here, if I would do 2 minus, I'm doing 2 minus 2, negative 2, that's why I put where 2 is located, on the top. If I would have what 4 minus 2, then I would get 2 and I would write down where 4 is located. So whatever is first number, that's where it goes. Okay, because you subtract from 4. So now 4 became 2. Now 2 became negative 2. 4 became 2. That's why writing instead of 4. Here we're writing instead of 2, negative 2. Okay, so I wrote down negative 2. Or I could write down practically y is equal positive 2. But do 4 minus 2 because 4 is bigger. So 4 minus 2 is 2, and write down where 4 is located. And here I would have only 1 left. And we got the same answer anyway. So whichever path you take, as long as you're solving correct, you will end up with the same answer. Okay, this is negative exponents, and then I will record scientific notations.